Hey, hello guys. Today's video, I believe is the last in this transfinite numbers uh, series beyond infinity, and it concerns absolute limits. So let's get started. So, the title of the slide is called the undecidable, and this is because linking to the previous video, um, which mentioned the continuum. We currently, with our level of maths and with all the rules we have in place in our current set theory and everything, we do not have the mathematical tools to prove or disprove um, the continuum hypothesis. So this means we do not know if there's another transfinite number in between aleph null and the continuum 2 to the power of aleph null. So I guess it shows that math is completely undecidable. We don't know this yet, but maybe one day we'll develop new tools in the realms of set theory to be able to definitively say whether or not there is another number between transfinite number between aleph null and 2 to the power of aleph null. So as you can see, you can't disprove the continuum hypothesis. Gödel and Cohen both found that this is the case. Um, so this isn't directly about transfinite numbers, but I guess it's some paradox which is linked to it. And so there's this thing called the axiom of choice, and using it, you can slice a solid ball into 5 pieces and reassemble them into 2 identical balls of the same size. So this obviously doesn't make practical sense in real life. However, it assumes that the ball is made from a it's made of aleph null sort of particles. So if you were to divide aleph null by 2 or by 5 in this case, you would be able to assemble it still into 2 identical balls of the same size, which is interesting to think about. Gets links to transfinite arithmetic, the way that it doesn't obey the usual laws of adding, subtraction, and division. So we've got proper classes. So if we try to make a set of all sets, it creates the Russell paradox. So we call these collections proper classes. The collection's so massive that they are too big to be treated like sets. So this is sort of obviously infinity, the transfinite number and infinity goes on forever. But because of this technicality introduced due to the dawn of the new set theory, I guess you could say there is an actual end, a limit, a horizon to how big numbers can get, and that would be proper classes, because it's too big to be classified by ZFC set theory. So technically, it's the largest mathematical object that is possible. And Cantor believed that at the very top sits the absolute infinite, and it cannot be measured, matched, or understood by mathematics. So this is sort of delving into more of the philosophical side of maths. Um, it's obviously not something you can actually prove that exists, but it's just a uh, sort of a hypothesis that will never be able to be proven or disproven. Maybe it will one day, but I guess it makes sense that there has to be sort of something that is outside of the realms of maths that is um, larger than all transfinite numbers. So sort of similar to proper sets in a way that it operates outside of our current understanding of set theory, our current mechanisms of set theory. Um, yes, those are the sources of all my images. Not that I'm going to get copyright strike. I get no views anyway. So, but yeah, I believe that's the end of the series, end of the slides. So it's been a pleasure talking to you guys about transfinite numbers, and there'll be a new series out on a new, different, um, university level topic. But I think this time I'm going to delve into statistics instead of number theory. What is this, number theory? I'm not sure it's number. I'm not sure this is number theory, but yeah, we delve into statistics next time. So I hope to see you in the next series. Stay curious about maths.